Assalamualaikum warahmatullahi wabarakatuh. Today my name is Muhammad Faris Haikal bin HAFIZ, matric number CN200-129. I would like to present about my group technology design project, which is smart exhaust kitchen fan. So our group consists of 4 persons, which is one Muhammad IZHAR, me myself, Haikal, MAHIRAH, and also SYAHIR. So for the introduction, our group project is our group project goal is to make an automatic fan system where the motor is controlled by the surrounding and room temperature. From this, the smart exhaust kitchen fan can automatically run or turn on while the sensor detects the designated temperature. So the problem statement, the main purpose of this project should exist in the world is to reduce the rate of fire in the house or building, so that it can also reduce the death rate that occurs. As you can see from the worldwide statistics, according the fire factor have been made, half of the total statistics are due to kitchen appliances. Therefore, we take note of the studies that have been done, and it underlines that the most common cases are more centered to negligent of kitchen users. So, a little bit more about our project. So, this smart exhaust kitchen fan starts to work when it detects a temperature around it, which is usually used in the kitchen for cooking or baking food. But when the temperature limit is set, for instance for our group project it is 60 degrees Celsius, the exhaust kitchen fan operates using thermistor. The first stage starts when the connection to the power supply, and directly the green LED will light up as well as the LCD displaying the current temperature. When the temperature sensor detects the heat more than room temperature, which is 20 to 30 degrees Celsius, it will make the motor to turn on the fan, and the green LED will turn off while the red LED will lights up. The red LED function is to tell that the room temperature changes over 40 degrees Celsius and the fan is running. The motor is used to turn its blades, which is function to pull out the air from the space. Hot air or smoke can be rotated until it is removed from the area of the home, and each temperature reading has been displayed on the LCD, which is placed as an easy determined current temperature. So our project aim is to the smart kitchen exhaust fan is equipped with the high-tech safety system based on microcontroller system. This project works using an Arduino system, temperature sensor, and also GSM, which is the global system for mobile. The main aim of the project is to prevent fire at earlier stage with the help of heat detector through sensors. So the project objective is to build a high-tech fire safety based on Arduino system, to study the ability of the Arduino system in improving safety or health prevention that occur in the cooking space, and produce an automatic fire prevention system that detect early signs fire that will occur through notification system, which is the GSM. Our scope is divided into 3. One, emits heat automatically when the temperature starts to rise. Second, activate the buzzer to warn when the temperature exceeds the limit, and finally to give a signal to remind the user. That's all from my part. I will continue. I will let my friend continue the presentation. Thank you.
Hi, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad SYAHIR bin RAMLAN. Okay, today I will talk or present about literature review that we get before doing our project smart exhaust kitchen fan. We have 6 literature. So the first one is automatic smart kitchen system using microcontroller. Okay, this project using temperature sensor sense the surrounding temperature, and it will display on the LCD. Okay, the speed of the motor is controlled by using PWM technique according to the surrounding temperature. Okay, for processing analog signal, the microcontroller has analog to the digital converter, which convert analog signal to the digital ones. Okay, the temperature sensor LM35 interface to the analog port acquired the surrounding temperature and convert it into a digital voltage signal. As we can see on the picture, this is our simulation. Okay, for the second, we go to the smart ventilation power generation, smart smoke ventilation and power generator, SSVPG. Okay, this simplifies this project overview on SSVPG. As the ventilation system detect smoke or an temperature difference, it will automatically turn on the exhaust fan to provide a stable room temperature and smoke-free environment. Okay, the exhaust fan spin the couples AC generator to produce 75 watt that will be rectified and then stored in the battery storage at the battery together with the solar power to either look back to the exhaust fan or use it to supply other equipment. Okay, as we can see here, this is how as we can see the picture, this is how the system will run. Okay, we go to the third. The third one is automatic exhaust fan has leak detector. Automatic exhaust fan and gas leak detector. Okay, this project aim to make a detector gas leak and on the kitchen exhaust fan that can connect or give an alarm direct to the phone, like LPG leak, butana leak, methanol leak, or any such as petroleum based gasoline substance that can be detected using MQ5 sensor. Okay, set up an SMS based alert mechanism and send 3 SMS to 2 specific mobile number that we programmed on Arduino. Okay, to produce a sound alarm, you print the gas leak and stop the alarm once the gas leak is under control character. Okay, for safety caution, avoid any accident for the resident. Okay, we go to the next. Number 4 is about IoT based smart exhaust fan. Okay, on this project to design and build IoT based smart exhaust fan which can turn on and turn off automatic, depends on temperature and air quality. Okay, as we can see, this is our prototype, and then this is how the prototype will work. Okay, we go to the next, number 5. Number 5, we have a temperature based speed control of fan using Arduino. Okay, this project is to be developed a low cost user friendly automated temperature controller, fan regulator which reduce power consumption and also assist people who are unable to control the speed of the fan from their location. Okay, the motor rotor will on state and will be rotating at 20% of maximum speed. If the temperature sensor value is equal to the to two motor rotor will be on state and will be rotating at 80% of the maximum speed. If the temperature sensor value greater than 29, motor will be on state rotating at 100%, so it will in maximum. As we can see here, this is the prototype for this project. Okay, for the last one we have for the sixth last one we have automated smoke detected exhaust fan. Okay, this main purpose of this project has been designed and circuit to detect smoke and consequently turn on the fan. This object was made since the system worked effectively. The cost of implementing this system is relatively low since the component used are relatively cheap and are easily available in the market. Okay, the single microcontroller can be used to interface the sensor with the relay as long as the more pins are freed for multiply input or multiply output. This system can be great in a domestic as well as industry setting to detect smoke and alert people of an implementing fire since smoke is preferred of fire. Okay, that's all about literature review that we get for our project Smart Exhaust Kitchen Fan. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad IZHAR bin ZAHARI. Number matric DN210073. So I will continue the presentation by my part, which is the methodology. So first we go to the block diagram. The block diagram is just divided to the two parts, which is the work process and component usage. So for the work process, it just show the working principle of this project step by step. Okay, and then the component usage just show the all of the component that we use to complete our project. Okay, next we go to the flow chart. So for the flow chart system, this is our flow chart for the project Smart Exhaust Kitchen Fan. The flow just show the operation project more detail with the input and output. Okay, and then next is the project circuit diagram. So this is our project circuit diagram that we design in the Tinkercad. We use a Tinkercad because it's very simple to use and practical because it just can run like a real hardware project. And then the last one is for the methodology part, is hardware usage. So for the hardware, we just use the all of the component that instruct by the coordinator. First, as we can see, Arduino Uno R3, LCD, resistor, 1 kilo ohm and 220 ohms, buzzer, motor driver, L298 and model, LED, red and green, potentiometer 1 kilo ohm, relay 5 volt, motor 12 volt, GSM and TMP 36 temperature sensor. So the total of the hardware usage is 113 ringgit Malaysia. So that's all for the methodology part.
Hi, Assalamualaikum. My name is MAHIRAH and I will explain about result and discussion. So for result and discussion, this high security exhaust fan project uses many high technology components in the system, and each component needs to be analyzed in more details to prove there is no doubt to future generations about the technology, especially on the main component that we use in this project, such as Arduino Uno R3, motor, buzzer, LED and GSM. Also, here we can see the project installation process for testing is started by using TinkerCAD software as the main center to create circuit and the test coding before the project creation process, because this is stage trigger the project success. Okay, next for the workability of the prototype, and this is the ideal speed test of DC motor. This is analysis table for temperature and motor speed, and based on the results shown in the table, it can be implemented in the project where each of the 6 experiments yield positive result, and this could have an explanation connected between servo motor code with Arduino, and this data is taken to see whether this motor speed is effective. And also this test requires temperature support to test the motor's ability to move. After doing these 6 experiments, we can see from the result that all these experiments went as expected. Next, for efficiency test of the thermistor or temperature sensor, the table show the comparison between normal temperature and TMP36. The reading and comparison in table show that the difference is quite different. However, the percentage of error sector found is not on a large scale, which causes TMP36 to be relevantly still used as the main trigger of the project. Furthermore, based on readings at normal temperature and TMP36 is not much different, the calibrations used also play as a role for the temperature sensor because it varies quite a bit. For the durability of the prototype, we collect the project data according to the experiment that has been carried out. The things that has been tested is the workability of the prototype. The test conducted is the ideal speed test for a DC motor. There is also an analysis that shows the accuracy of the motor speed and temperature sensor. Then the test will test the efficiency level of the thermistor or temperature sensor. This experiment tests TMP336 ability to withstand normal temperature. We also test the durability of the prototype, and this result can be seen in the table that I will show after this. Okay, for the first table is the value of current and voltage below 40 degrees. And next, the value of current and voltage more than 40 degrees. And lastly, the value of current and voltage more than 100 degrees. In conclusion, we have succeeded in producing this project effectively, starting from a proposal to the result of hardware for this project. We managed to achieve the main objective, which is build a high-tech fire safety system based on the Arduino system. We also can study the Arduino system's ability to improve the safety of the fire prevention in the cooking space. Not only that, we can also produce an automatic fire prevention system that can detect early signs and fire that will occur through a notification system that is GSM to the homeowner's mobile phone. Lastly, this is references that we use to make this project, and that's all from us. Thank you.